Hi everyone, very good evening and welcome back to Geeks for Geeks practice. Please give me a +1 in the chat if my voice is clearly audible to everyone and everything is working fine. And then I will share my screen and we'll discuss the problem of the day for yesterday. That was least prime factor. Hi Rishit as well. So guys, please hit the like button and then I'll start off with the problem. All right. So very good evening to Rishit as well as always. So what we will do is I'll quickly share my screen and then we can start discussing the problem. So let me add my screen to the stream, and now I think we can discuss this problem. Okay. So what does this problem say? First of all, let's have a look at this particular problem. Let me reset the code. Okay. So this problem basically says that you have been given a number n and you have to find the least prime factor of all the numbers starting from 1 to n. Okay. So what does this mean? Basically they are saying that suppose you have 1. Okay, then you have 2, then you have 3, then you have 4, then you have 5, then you have 6, then you have 7, then you have 8, then you have 9, then you have 10. Suppose you have been given the n value as 10, then what you need to do is you need to return an array, one based index, in which you need to tell what for every element what is the lowest prime factor for it. Okay, what is the smallest prime factor that divides it. So you can see here that for 6 the answer will be 2, for 2 the answer is going to be 2, for 3 the answer is going to be 3, for 4 the answer is going to be 2, for 5 the answer is going to be 5, for 10 the answer is going to be 2 because 2 is the smaller one. Then for 8 the answer is going to for 9 the answer is going to be 3, for 7 the answer is going to be 7, for 8 the answer is going to be what, 2. Okay, if you will talk about the element, let's say 11, I'll write 12 also, 13 also, 14 also, 15 also, 16 also here, right? So for 11 the answer is going to be what, 11. For 12 the answer is going to be 2 because 3 is bigger than 2, right? So I'll write 2 here. Then for 13 the answer is 13. Then for 3 for 14 the answer is going to be 2. For 15 the answer is going to be 3 because 3 is smaller than 5, right? Then for 16 the answer is going to be 2 again. So is this part clear till now, right? What they are expecting from us, if they give us n value as, let's say, 16. So for 1 they are expecting, I think, the answer as what? For 1 they are expecting the answer as 1. Yeah, for 1 they are expecting the answer as 1, for 0 they are expecting the answer as 0, and for the rest of the elements they are expecting that for 16 you have to write you have to give 2 as the corresponding answer. So is this much part clear? If this much part is clear to all of you, then please hit the like button and then I will tell you about further how we can solve this problem. Okay, please hit the like button and give me a +1 in the chat, guys, if everyone is clear till now, right? If they have given a particular n value, so they want you to return an array which consists of the smallest prime factor of that number. So for 1 the answer is 1, for 2 the answer is 2, for 3 the answer is 3, for okay, then you have 4, for 4 the answer is 2, for 5 the answer is 2, for 6 also the answer is 2, for 7 the answer is 7, for 8 the smallest prime factor is 2, for 9 the smallest prime factor is 3, for 10 the smallest prime factor is 2. Okay, so is this much part clear? Please hit the like button and give me a +1, guys, if till this much point everyone is clear, and then I will proceed further. All right, so now let's proceed further as well. Okay, you can hit the like button if you're clear with this part. So what we can do is, now we know an algorithm, that is sieve. We know the sieve algorithm, right? In prime numbers we know that we can use the sieve algorithm, right? So here also, now, for solving this problem we can use the sieve of Eratosthenes approach. Okay, so we can use the sieve approach for solving this particular problem. Okay, for solving this problem what we can do is we can use the sieve approach. Now what does it mean by the sieve approach? So what I will do basically is, let's say if I'll write the numbers, okay, if I'll write all the numbers, let's say I'll write all the numbers from 1 till 20. Okay, so I'll write 1 here, then I will write 2, then I'll write 3, then I'll write 4, then I'll write 5, then I'll write 6, 7, okay, 8, then let's say I'll write 9, then 10 I'll write here, 11, let's say I'll write 12 here, 13 here, 14 I will write here, 15 here, 16 here. Okay, let's say I'll write 17 here, 18 somewhere here, 19 here, 20 here. Okay, let's say I'll write 21 also, 22, then I'll write 23 here, 24 here. Let's say if I'm writing till 25. Okay, if I'm writing this particular point. Hi Vanshika Kapoor, very good evening. Right, so what I will do is, first of all, for 0 I'll mark the answer as 0, and for 1 I will mark the answer as 1. Okay, and what I will do is I'll start the iteration from 2. Okay, so initially I will do what, I will take an array and initially all the values will be marked as 0. Are you getting my point, guys? Initially all the elements will be marked with the value as 0. Okay, Initially all the values will be marked as nothing but 0. Is that clear? Is that clear? Like initially all the elements will be marked as 0. So let me mark them as 0 for all of you as well. Just give me a second. Okay, initially all of them will be 0, right? So initially I will mark all of them as 0, right? Now I will check. So if I check this guy, right? So when I check this guy, so it is marked as 0, right? So its value is marked as 0, right? So basically you can say, if I'm having an array, so a array of 2 is marked as 0. So this basically indicates that 2 is a prime number. Okay, if any value is 0, if I'm iterating now and any value is 0, okay, so then what I will do is I will simply say that I will update this guy to 2. Okay, instead of 0 I will update this guy to 2, and then I will say that, oh, if this is a prime number, so this means if it was 0, so this meant that it was a prime number. Now I will mark all its multiples as multiples with the value as 2. Are you getting that? I will mark a of 4 with the value as 2. Okay, I will mark a of 6 with the value as 2, because if 2 is a prime number, then all of its multiple will have the smallest prime factor as 2. Are you getting my point? Yes or no, guys? Please tell me. So for 4 I will mark it as 2, instead of 0 I'll mark it as 2, right? That is what I'm going to do. For 4 I'll iterate and I'll mark it as 2. For 6 also, instead of 0, if it is 0, so I'll mark it as 2. Okay, then 8 also I'll mark it as 2. Then 10 also I'll mark it as 2. Then 12 also I'll mark it as 2. For 14 also, the array value it will be updated as 2. For 16 also it will be updated as 2. For 18 2. For 20 it will be updated as 2. 22 2. For 24 it will be updated as 2. Right, this is what we are going to do. Now once this part has been done now, so we'll move to the next number. Okay, so basically what you can say is we ran a j loop starting from 2 into I. Okay, and j is less equal to n, you can say, and we marked all the j numbers as I, right? We marked all of them as I. If I was a factor, right? I is equal to 2 was a I is equal to 2 was a prime number. So if it is a prime number, so all of its multiples will be updated. If they are not updated, right? If they are not 0, if they are equal to 0, then they will be updated. Now I will come to 3. Okay, then let's say I will come to 3, guys. So please give me +1 if you have understood till now. When I come to 3, guys, then what happens? When I will come to 3, then understand one thing. When I come to 3, so I can say that 3 is 0. So this means 3 itself is a prime number, right? So I will say that, okay, in that case we will mark the 3 value as 3. Okay, we'll update this guy and all the multiples of it which are not updated. So we can see that 6 is already updated. So will you update 6? No. You can see that a of 6 or p of 6 is already marked as 2. So will you disturb 6? No, because for 6 the smallest 6 is already updated with the value as 2. So this indicates that for 6 the smallest prime number that is there, it is nothing but 2. Okay, so that is why you will not update with the value as 3, right? Because it is if it is 0, then only you will update. So for 6 it is already updated with 2, so you will not disturb this value. Okay, then you will go to 9. So you can see that at 9 it is 0, so you'll update with this 3. Then you go to 12. So you can see that a of 12 is already marked as 2. So you can say that for 12 the smallest number, okay, the for 12 the smallest number that is there is nothing but smallest prime number is 2. Smallest prime factor is 2. So we don't need to disturb it. If it is not 0, so we'll not disturb it. Okay, similarly we will go to 15 and we can see it is 0, so we'll update it with 3. Then we'll go to 18. So 18 is already updated with 2, so we'll not disturb it, because for 18 the smallest prime factor is nothing but 2. Then for 21 we'll update it with 3, because it is 0. Then for 24 it is already updated with 2, so we'll not disturb it. Okay, suppose we were going till 25 only, if the n value was suppose given as 25 only, right? This is what I am doing. Is this part clear to everyone, guys? Please tell me. So we are applying the sieve approach, right? Please write sieve in the chat. So we are applying the sieve method here, right? Sieve method. The logic here is nothing but the sieve method. Okay, but we are not we are not marking the prime numbers as true or false. We are storing the smallest prime number here. That is what we are doing. Okay, then after that what I can say is, when we'll look at the next guy, so for 5 we can see it is 0, so we'll update with 5. Then we go to 10. So we can see that 10 is already updated, so we will not update it. We go to 15, it is already updated. Okay, so we'll not update it because it is already updated with 3. Then we go to 20, it is already updated with 2, it will not update it. We'll go to 25, we'll update it with 5. Okay, then after that what will happen here is, then after that for 7 we will update it with 7, and 14 is already updated with 2. Then we can see that 21 is updated with 3, so we'll not disturb anything. Then after that 11 will update it with 11, right? And then the rest of the things will not get updated because of 11. 22 and other things are not going to get updated. Then for 13 it will get updated with 13. Okay, then for 19 it will get updated with 19. Similarly 17 will get updated with 17. and 23 will get updated with 23. So this is how we are going to store all the factors of it. Is this part clear? Please write +1 or clear in the chat. If all of you are clear, please write clear in the chat, and please hit the like button if you are clear with this, right? Is this clear? So basically this is nothing but the sieve approach that I have used, right? You can give me a +1 also, or you can write understood in the chat if you have understood it. So Rishit is saying clear, and Tejas Sai is also saying clear. Very good, guys, very good. All right, very good. Abhishek is also saying clear. Right, so this is how we are going to do it. And as we already know that for the sieve algorithm, what happens now? The time complexity is order of n log of log n. Okay, so that is why the complexity of our approach is going to be n log of log n, because that is the complexity of the sieve approach, and the that is how we are doing it. Okay, Matt Flash is also clear. Very good. So I will just now start writing the code as well. Okay, so just give me a second. So what we will do first of all is, let's say I will declare an int array, right? Sorry. So we'll declare a vector int array, let's say answer array. Okay, and initially I will declare it with n+1 size, and initially I'll mark all the values as nothing but sorry, since I'm declaring it with like this, so I should declare it like this. Okay, and initially all the values I'm marking them as 0, and then what I will do is I'll say that answer of 0 I'm updating to 0 itself, and let's say answer of 1 I have to update with 1. Okay, then we'll start the loop from I starts from 2. Okay, so I'll start the loop from 2, guys, and I will be lesser than equal to n, and then I will do an I plus plus. Right, just a second here. Then what we will do is we'll iterate through the multiples. So we can say that int, let's say j will start from 2, we will simply say that first of all, if it happens, right, if it happens that answer of I, okay, if it is equal to 0, so in that case this means that the ith number is a prime number, and we'll say that answer of I is equal to I first of all. Okay, so we'll say that for 2 its smallest prime factor is 2, and then we'll say that okay, j loop starts from where, 2 into I, right, the multiples, and then j is lesser than equal to what, j is lesser than equal to n, then we'll do a j plus j is equal to j plus I. We'll keep on iterating through the multiples, right? So it always increase by I, and then what we'll say is we'll say that answer of j is equal to if the answer of j is not updated, then we'll update it. So we'll say that if it happens that answer of j, if it is equal to 0, so if it has not been updated so far, then we'll say that okay, answer of j is equal to I, right? Because for 6, suppose that for answer of 6 it is already updated to 2, right? So in that case we'll not update its value, no, because when we'll come at it for 3, then 3 is not going to get updated for 6, right? Okay, so this is what we can do, and I think that in the end we can just return this answer. Okay, is this part clear, guys, or not? So this is what I'm thinking, and let's see if it works or not. So this is nothing but the sieve approach for solving the problem. Okay, it works fine on the samples. Let's check it for the submission and see if it gets accepted or not. I hope that it should get accepted without any issues. Yes, it does get accepted, right? So you can see that it gets accepted. So is this problem clear to everyone? Please tell me, guys. Is this problem clear to all of you? This is a very good problem, and I think this can be asked in many of the companies. So basically, this is how we solve this problem, right? Sieve approach, and the time complexity for the approach that I have told, it will be n log of log n. Why? Because we are using the sieve approach, and the space complexity will be nothing but order of 1 here. Okay, is this part clear? Guys, is this part clear to everyone? Please let me know, guys. Are you all clear with this part? Makes sense, right? Again, I am just zooming in the code part. So what I'm doing here is, first of all, you can see here, I have the answer n+1, and initially I have all the values as 0. A of 0 will be marked as 0, a of 1 is marked as 1. That is the question, what the question says basically. Can you write the time complexity? Some screen, it is not visible. Okay, because of me it is not visible properly. Okay, so what I will do is, no, just to give me a second, I'll go a bit down. So yeah, when I'm writing, time complexity is nothing but the time complexity of the sieve algorithm, so it will be nothing but n log of log n. Okay, it will be nothing but n log of log n, right? Because I am using the sieve approach, right? So in the sieve approach, the complexity is n log of log n, and the space complexity, if you will consider any extra space, so I'm not taking it, but if you will like 0 order of 1 extra space, right, because we are not taking any extra space, if you will consider the order of an answer that we have declared, so this is for the purpose of returning the answer. Okay, space complexity, how it is order of 1, because I am saying that this is the extra space, we are not taking any other extra space other than returning. So if you consider the returning array that you have to declare, then it will be order of n. But suppose if the interviewer tells you that accept the extra space that you are taking for the vector, what is it, so it will be order of 1. Okay, now somebody is asking that what, explain the time complexity, how it is coming out to be n log of log n. So I will explain that. Okay, so basically now what happens in the sieve is, in the sieve algorithm, the time complexity is order of n log of log n. Why? Because if you will see, so when my loop, how much times my loop is running, that is the number of times the time complexity will be counted. So if I will ask you one thing now, first of all, if I'll write this thing, so what happens is, if I value is 1, okay, suppose I is less equal to n, if I'm writing, and then I do an I plus plus here, and after that what I will do here is, if I write j loop, j starts from 1, okay, j is less than equal to n, and then I do a j plus plus, right, and this is the loop. So you will tell me that, okay, when the I value is 1, then how many times j loop is running? J loop is running n times. When the I value is 2, j loop is again running n times. When the I value is 3, then the j loop is again running n times. So when the I value is 4, then the j value is again running n times. So when the I value will be n now, then also it will be running n times. So I'm adding n plus n plus n, right, n times normally. So it is n square. Is that clear? The normal thing is clear? Please tell me, guys, then I will explain the further part. Is this normal thing clear? That normally, if I have this loop, so when the I value is 1, so the j loop runs n times. So the so n times it runs, right? Then I value is 2, then it runs n times again. Then I value is 3, again the j loop run n times. So it is n plus n plus n, n times, so n square. Is this part clear to everyone till now? Rishit is saying clear. What about others? I'm just moving it up, and now it will be clearly visible, right? So yeah, this part is clear. Now let's talk about R code. Can we talk about R code now? Okay, so if you will talk about R code, so how it is going to run. So if you will see, let's say that if you will talk about the code that we have, so when I value is 2, then it is going to run. Okay, so when the I value is 2, then how many times it is going to run? See, if you have n is equal to 50, suppose, so it is going to run at which values? It is going to run at 2, 4, 6, 8 up till 50, right? So for how many values it is going to run? Anybody can tell me? For how many values it is going to run? Anybody can tell me? Anybody? Like, can I say it is going to run for 25 values, right? It is going to run 25 times, right? 25 times. Can I say this, guys? Yes or no? Half of the values, right? Because run 2, 4, 6, 8. So it is running 20 this time. So I can say it is running n by 2 times, right? So when this value is there, so it is going to run n by 2 times, right? After that, suppose that when the I value is 3, then what is going to happen? When the I value is 3, okay, then you can see it is going to run 3, 6, 9, right? Up till what? Up till I think 48, right? So how many times it is going to run? It is going to run n by 3 number of times. Okay, please write n by 3 in the chat, guys. Divide by 3 in the chat, n by 3 in the chat if you are clear, right? So hi Naikaj as well. So now it is going to run n by 3 number of times. Okay, when I is going to be 4, is the loop going to run? No, because is the j loop going to run? No, the j loop is not going to run, because 4 is already updated. So it will run all for all the prime numbers. Now when the I value is 5, so how many times it is going to run? Anybody can tell me? Anybody can tell me when the I value is 5, then how many times it is going to run? Then it is going to run n by 5 number of times. Okay, so it is going to run n by 5 number of times. All right, then after that, when the so let me write this. After that, when the I value will be nothing but 7, so it is going to run for how much times? It is going to run n by 7 number of times, right? That is what is going to happen, right? So similarly, it will keep on running. So if you see, so it will be n by 2 plus n by 3, okay, plus n by 5 plus n by 7. Okay, then after this, if you will resolve this particular series now, so what will be there when you will take n as common? Now take n as common, right? So just a second, let me write this. So this will be n by 2 plus n by 3 plus n by 3 plus n by 5 plus n by 7, right? So on and so forth, right? So then the series will be, if you take n as common, right, so it will be 1 by 2 plus 1 by 3, okay, plus 1 by 5 plus 1 by 7, okay, so on and so forth, until it goes till the value, right? So prime numbers will be there, right? So this is the thing. So now you can observe in this series what happens now. If you will see, this is nothing but a harmonic progression. Okay, this is nothing but a harmonic progression. So I'll write it, harmonic progression. Okay, so this is nothing but a harmonic progression here. Now what is the sum of this harmonic progression? So if you know 1 plus 1 by 2 plus 1 by 3 plus 1 by 5 plus 1 by 7, okay, plus this thing 1 by what, 1 by 11 and all that, the sum of this harmonic progression is nothing but this thing, it is log of log n. Okay, if you will solve it by using integration and all those methods, then it will come out to be log of log n. So that is why the overall complexity is n log of log n. Is this part clear, guys? Please write +1. Is it clear? I have derived it today for all of you. So that is why the complexity of my code is going to be n log of log n, because the harmonic progression, the sum of this harmonic progression is going to be log of log n. Okay, the sum of the harmonic progression is going to be log of log n. Okay, when you will solve this the series. So that is why the overall time complexity is going to be n as common. Then this will be nothing but overall log of log n. The sum of this series is log of log n, because this is a harmonic progression. Is it clear to everyone, guys? Please tell me. Now, does it make sense? At least you have understood from where the relationship comes from, right? Yes or no? Please hit the like button, guys, if you are understanding this clearly. I hope that you have understood it very, very much clearly, right? If you have understood it, so please, for this derivation, at least you can hit the like button, guys, right? For this derivation, you can hit the like button, na? We have tried to derive it from the starting. Not n, it should be square root of n. No, 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 no. Here it will have n. I have to take n here. So we are not going till the square root. We are not going till the square root, because here we have to update 19 and other elements also. Now, Naikas, the thing is that we have to update 11 and 19, all those elements also. So that is why we are not going till root n. This is going till n normally. So yeah, is this clear? N log of log n is going to be the complexity. Guys, please hit the like button and give me a +1 in the chat if everyone is clear with this, right? At least the like counter should reach till 10 na? Today, tonight. Is it clear to others? Please write +1 in the chat, guys. All of you can tell me. Tejas, Naikaj, and Rishit is there. Then Abhishek is there. Allah Bonia is there. Then Mad Flash is also there. Other people are also there, right? So yeah, you have understood this clearly, I hope. All right, very good. So please hit the like button. In the meantime, you can take a screenshot of this as well, right? If you want to, and I will just generate the link of this code. Okay, just give me a second. Yeah, so I'll just quickly generate the code here. Thanks a lot, Abhishek Dharmaraj. Okay, so this is the link, and let's paste it as well. Yeah, I'm copying it and I'll paste it in the chat. Okay. Yeah, so I've pasted it in the chat again. Just to summarize it, I'll move a bit up, as I already told you. So we use the sieve method, right? So for a particular number, if it is already updated, because the Naikas, the thing is that we will not move till root n, because we have to update for 17, we have to update the value as 17. For 19, we have to update the value as 19. Now, so that is why we cannot go till square root here. Okay, and then when you move down, so as I've already said, if you have a normal loop, I start from 1, I is less than equal to n, and j start from 1, j is less equal to n. So when I value is 1, then you have n iteration. Then I value is 2, you have n iteration. I value is 3, you have n iteration. So n plus n plus n, n times. So that is overall equal to n square, right? So similarly here, what I said was, when you will derive this particular time complexity, so I value is 2, then it is running n by 2 times. When I value is 3, it is running n by 3 times. When I value is 5, it is running n by 5 times, right? So that is why overall n plus n by 3 plus n by 5 plus n by 11 and all that, when you will take the sum of that harmonic series, right, then it will take this much time. I have done using the square root n. So your complexity is under root of n. Okay, your complexity is under root of n or n root n. But yeah, I don't do n by I in the inner loop. Okay, okay, okay. So yeah, this problem is clear to everyone, guys. Please write +1 in the chat and hit the like button. Is it clear to all of you? Did you enjoy this problem? Please write +1 and enjoy it in the chat. Understood this problem clearly, everyone? Please tell me. All of you have understood this clearly. I hope that. Okay, so that was it for today's problem of the day, guys. If you're watching the recorded session, so make sure to hit the like button. And with that being said, I'll see you tomorrow night with another problem of the day. Thanks a lot, and keep coding, guys. Keep solving the problem of the day. Thank you everyone for joining, and thank you for this session. Thank you everyone.